Hello everyone, my name is Havva. I'm a master's student in chemistry at Bulaban İzzet Baysal University. Now I will give you some information about my work called Synthesis of some new thiazolene-thiazole substitute compounds. I prepared my presentation in 6 categories. These are introduction, other properties, synthesis of thiazolene and thiazole, working plan and aim of study, results and discussion, conclusion. Fragrance and flower substance are comparatively strong smelling organic compounds with characteristic usually pleasant odor. They are therefore used in perfume and perfumed product. From the early 19th century, development in chemistry began to create the flower and fragrance industry as we know it. At present, thousands of natural or synthetic odor and never odorant substances are defined precisely as molecular structure and available by chemical synthesis. There are many other compounds exist such as aldehyde, alcohols, ketones, esters, and heterocyclic one. Heterocyclic molecules are significant due to their high abundance in natural and their chemical, biological, and other properties. We especially focus on the thiazolene and thiazole compounds that are members of this group. Thiazolene are a group of the 5-membered heterocyclic compounds containing both sulfur and nitrogen in the ring. Alpha and substitute thiazolines are rarely encountered themselves. Their derivatives are more common. Thiazoles are the oxidase form of thiazolines. Thiazole is the aromatic on the basis of the delocalization of the lone pair of electrons from the sulfur atom completing. Sulfur-containing odorants leave a shadowy existence in the fragrance chemistry. The reasons are most often their obnoxious and pleasant odor when smelled at a high concentration, their instability towards the oxidation, and, in addition, the prodigious generalization of this fact leading to the opinion that these compounds can be readily incorporated into perfumes. But this idea is wrong, because many sulfur-containing odorants which add an olfactory effect to the natural scent were also found in various fluids, essential oil, absolutes, and resins. Depending on the type of substitutions in the heterocyclic ring, thiazolines and oxide-formed thiazole can produce a variety of olfactory notes, ranging from fruity, green, and vegetable-like to nutty, butter-like, fatty, caramel, or to smoky, spicy, and meat or to fish-like. Now I would like to talk about the method I used for the synthesis of thiazolene and thiazole. Process in which substitute thiazolines are synthesized by method described by Albert Mayer is known in the literature. In the first step of this procedure, the nitrile react with HCl gas and ethanol to turn into the carboxymidate. In the second step, when this carboxymidate reacts with cysteine methyl ester, cyclonization occurs and thiazolidine compound is formed. In the thiazole synthesis, although there are many different oxidation methods available, I used the method Schauming-Wu and co-workers described using molecular oxygen as an oxidizing agent to convert thiazolene to thiazoles. One of the biggest reasons I prefer this way is that it is low cost, high yield, and environmentally friendly. Firstly, I would like to tell you about the purpose of this study. Various carboxymidate compounds will be prepared by multi-step group transformation, starting with fragrance aldehyde, and thiazolene substitute compounds will be obtained from synthesized carboxymidate compounds. In the first step of this procedure, benzaldeoxime was obtained by the reaction of the aldehyde and hydroxamine HCl. This benzaldeoxin was heated with concentrated HCl and converted to nitrile. After this step, the procedure described by Albert Mayer, which I have explained before, was applied, and thiazolene substitute compounds were obtained. Then the obtained thiazolene were converted to thiazole by oxidation reaction. Product 1 and product 2 were obtained as the expected product from the way I mentioned in the working plan. As shown in the figure, the proton NMR result of synthesized product 1 is support for the molecule. Protons close to the sulfur atom are respectively 3.68, 3.62 ppm. The proton close to nitrogen atom was observed as 5.28 ppm. When we look at the result of the product 2, there is no ping around 5 ppm. At the same time, it was observed that the proton close to the sulfur atom was 8.15 ppm in the more shielded area. The cause for this due to the movement of the electrons in the p bonds of the carbon-carbon double bond. The other result was carried out by expert noise. Product 1 was found to be solvent-like, product 2 was found to be heliotropin vanillic other characteristic. Various immediate compounds were prepared by multi-step group transformation, starting with fragrance aldehydes and thiazolene and thiazole substituent compounds were synthesized from the obtained immediate compounds. All synthesized thiazolene and thiazole were characterized by IR NMR mass spectra. The synthesized compounds were tested olfactory evaluation. Some of them provided fragrance notes. Thank you for your attention and listening to me.